Review real quick where we left off Thursday. We had gone through several iterations of a controller of an MVC application, and we had started with a really simple one with some caveats, right, where the view had direct access to the model, and we said that's a no-no. We iteratively made it several improvements. The first one was to decouple the view from the model by putting a control in the middle, and then we added a couple more features. We continued the decoupling. Eventually, we applied the command pattern, and then we even decoupled the controller from the view, right, by using the set of features, right, that no longer would be using low-level event handlers of action listeners and key listeners. We created our own interface, right, where the view could notify the controller with this high-level event handling. We then abandoned that a little bit, and we turned our attention to the turtle example that we had started about a week before, but we had not used any of this rendering on the screen. We were just spitting out all the output to the console. So we went over the turtle runner. I think we borrowed the same model we had come up with about a week earlier, right? The turtle model, and we kept that. We just started adding more control and perhaps the view. So on Thursday we took a look at the data model for representing points, for representing the lines. This is the same turtle model that we had reviewed a week earlier. That's being able to just trace, save, move, turn, right? All the basic operations. We then, I believe, we covered extracting the model outside of the controller, right? And we applied the command pattern where we encapsulated all the various actions inside of dedicated classes, right? All different classes that all implemented this particular interface. The TracingTurtleCommand implemented this one function, Go, that took as argument the model, right? And then each command class operated on this model, right, in various ways. The move, the trace, the save, they all operated on various parts of this model. Right, when we call Go, we pass a reference to the model, and then the execution, applied the transformation on the model. For instance, the move told it, well, how much do we want to move? But the move implementation was on the model, right, which we're passing along here. Same thing for turn, for change, for save, trace. They're all the same, right? We pass in a reference to the model so that each one can then operate back on the model. Also square, right, which was a kind of like a encapsulation of multiple traces and multiple turns. Right, so it kind of hides the details of from the controller's point of view. Right, it's delegating on these command patterns to do what they're supposed to do and act in the model the way they're supposed to do. The controller doesn't know anything, right? The only responsibility for the model for the controller is to shuffle data back and forth between the view and the model, right? It says, well, this is how much they want you to turn, and then passes it to these commands, and then the commands are then in turn manipulate the model. For the controller, we did implement a couple of functions. This is with the intention that perhaps we could create a more generic controller. Ours is one particular implementation of the controller, but we saw that in the previous examples that we could iterate over multiple versions of the controller, even creating one that allows you to rip out and decouple the view from the controller, right? By implementing a particular interface. Ours was the one that the one that was most sophisticated was the one that implemented the feature, right? Here we're not going that far. Right? We're not going as far as implementing features, but nevertheless, implementing these interfaces would allow us to perhaps implement even something more interesting. This is the MVCCommand Controller that when it gets instantiated, gets a reference from both the model and the view, right? So that it has so that the view will never have access to the model directly, only through the controller. It's responsible for shuffling back and forth and having reference to both. So yeah, as the instantiation, we initialized as the model and the view. That's trivial. We're still dealing with low-level event handlers. So button click or keystrokes. We're still implementing the action listener interface, as a controller. Right? Notice that. So we don't have the high-level implementation of the features like we did on our previous example, right? We're still dealing with low-level event handlers like you pressing a button or typing at the keystroke. So we're still low-level event handling. And again, we didn't go as far as implementing feature, which would be really, really cool. So right now, the controller and the view are very tightly coupled. Right? They still know about each other. They still the only way that they communicate is through this low-level event handling. But again, it'd be nice to go even further and add features in between. So because it's implementing that action listener interface, it needs to implement this particular function, right? The action performed, right? All classes that implement that interface get notified through the action perform method. So the view, as you click on the buttons, as you type on the input field, as you move the mouse, right? The view will be responsible for notifying the controller through here, right? Putting the controller as an action listener. Say, hey button, if you're clicked, you got to notify the controller, right? Not me. The view doesn't know anything about it. And the controller, what's going to do is it's going to process a command. Presumably, these commands are things that you type at some input field. Move 20, trace 30, turn 90 degrees, and then we press some buttons saying, hey, execute it. And the button is going to notify this action performed. Say, hey, somebody parse the command. That's what process command is going to do. It's going to go back to the view and say, view, what is it you want me to do? Right? It's going to read an input field and say, oh, okay, the input field will say move or turn or trace, whatnot. And the process command will be responsible for parsing that input field, that command that you type, and instantiating the various command patterns, right? The move command pattern or the turn command pattern. Each one of those will instantiate one big switch statement, right? An infinite loop checking, until somebody quits, checking, processing each one of these commands, and then executing it. Once it executes, those commands, right? The move command, the turn command, they will all update the model. Yes. So by the time we come back from the process command, presumably the model has modified. Right, it has a new line. It has the turtle has moved. The turtle has turned. Whatever, right? And then so we can now iterate over the view and say, hey, the model has a new line, right? Or the turtle moved. It has a new position. So the controller is gonna, after having updated the model, it'll notify the view, hey view, these are the new lines. Here's the new position of the turtle. Refresh yourself. Re-render yourself. Right? Render the new version of the view, and the view will oblige and erase the old graphics and then re-render. So anyway, so this is process command. So this is the second line here, right? I'm getting the process command, and the command, as I mentioned, right? It's just gonna take the string from this string comes from an input field, right? That we're going to look at the view when we get to the view, and it's going to use the same technique that we used earlier for consuming text from the console, but instead of the console, we're going to consume it from just a plain string. And this is a tight loop, parsing strings, doubles, integers, and it's just one big switch statement. So basically, this is the implementation of a finite state machine. So the controller basically is one big finite state machine, right? Depending on the various inputs, it'll transition from one state to the next. So it's a very simple finite state machine. and it'll consume the various commands: move, trace, turn, square, depending on your input. It instantiates these command patterns, and at the very end, if the command was not null, it executes the model. Right? It says command go. Do what you need to do, right? For either its turn or trace or move or turn or any one of those, right? It's embedded. It's inside of the command. Notice that we could have made this even nicer and more sophisticated by going through perhaps a hash table, right? Where all these commands would be keys to this hash table. Right, as opposed to this one big switch statement. Right? This is very low level, and it's much harder to expand. Right? If you want to add new commands for the turtle, right, you need to add new switch statements in here. Right? So this makes it hard to expand this controller. But we saw other implementations where we would use the map instead, right, where we can add new entries to as new keys that allow us to expand this much easier. So anyway, so at the end we execute the command. Whether this command is from here, from the switch statement, or taking it out from a hash table, hash map, we can return the all these lambdas stored in the hash table. Would be really nice. We don't have that, but certainly it'd be a definitely better improvement. So if the command is not null, we execute it and we append the output. Yay, we were able to execute the command. All right, so let's take a look at actually rendering these lines, rendering the turtle rendering. We haven't looked at that, so let's do that next.